In the early 1910s, a German meteorologist named Alfred Wegener was playing a puzzle. Well, a mental one. It was probably the largest one ever imagined, because the puzzle pieces were Earth's 7 continents. He noticed that the continents almost looked like they fit together. Just look at the eastern border of South America and how it fits together with the western border of Africa. Wegener hypothesized that 200 million years ago, the continents were connected in one large supercontinent called Pangea, and over time drifted apart. Hence the name of his theory, Continental Drift. He had 2 main pieces of evidence, fossil evidence and matching geological units. Wegener saw that fossils of plants that seemed to only be able to live in tropical climates were found in areas with cold, snowy climates, like Antarctica. This pointed to the idea that continents were not always in the same place, and that a continent like Antarctica could have at one point been close enough to the equator to have a completely different climate than it does now. Also, fossils of the same species existed on different continents, which are separated by large bodies of water that those species could not travel. This suggested that not only did the continents move, but they were also connected. When glaciers move, they leave marks in the ground, called glacial striations. Think about the glacier like sandpaper, that scrapes and leaves paths in the rock. Glacier marks, or striations, have been found in areas with very warm climates like India, suggesting that those places could have been farther from the equator than they are now. These glacial striations, along with mountain belts, seem to connect across continents separated by oceans, again suggesting that they were not always so. What Wegener was really missing in his theory of continental drift was something that proved that the Earth's landmasses actually do drift, and explain how they do so. Does land float on water, allowing people and animals to swim under it? Is land less dense than ocean water, allowing it to float like ice? What else could possibly explain how these giant landmasses moved? Well, Paleomagnetism was the real answer Wegener was missing. It is the study of how Earth's magnetic field over its past has been recorded in rocks. When geologists studied the solidified magma from volcanoes, they saw that the magnetic properties of samples from different time periods were different. Essentially, what this showed was that over the course of about 1 million years, Earth's magnetic field reverses. This can be conceptualized better with a compass. In this current magnetic field, north points up, but when the magnetic field reverses in the next hundreds of thousands of years, north will point down. Rocks take on the magnetic properties of the Earth at the time they cool, making them function as a tape recorder. How did this help explain how continents moved? When geologists measured the magnetic properties of the ocean floor, they noticed that it alternates in strips parallel to structures, which are known as ridges. Seeing this, geologists were able to conclude that new hot magma rises from these ridges, takes on the magnetic properties of the Earth at those times, solidifies, and pushes crust away in a process called seafloor spreading. So how does this work? If the seafloor were continually spreading, wouldn't the surface area of the Earth just continue to expand? Well, no. Actually, just as the seafloor spreads in certain regions, it contracts in others, keeping the overall area of the Earth the same. These areas are called subduction zones. With these 2 phenomena, Earth's crust and appearance is constantly changing, just really slowly. The last piece of evidence is a result of Earth's plates moving and a structure called a hotspot. A hotspot is exactly what it sounds like, a very hot region in the mantle, from which magma can rise through all the way to the crust. When this happens, islands and volcanoes could be formed. And since the crust moves, while the hotspot, which is below the crust, doesn't, multiple islands could be formed in series. An example of this chain of islands is Hawaii. This again shows that the crust does in fact move. Now, a new theory, plate tectonics, is widely accepted and is responsible for explaining different types of boundaries, like transform, convergent, and divergent, and mountain and volcano formation. All the ideas began with a simple puzzle that led to more puzzles. Now the next time you go outside or look at a map, act like Wegener, and try to find a puzzle, then try to solve it.